Okay.
Uh,
Yeah. Actually, yeah, you can go ahead and just introduce yourself. Go ahead and
okay,
yep.
okay, thanks.
Yeah. Thank you.
Yeah, okay, so my name is Ezequiel. Uh, I have been an ESGF Tier 2 data node admin for 7 years now, and a couple of years ago, I have also started my PhD, and I work in Spain in Instituto de Física de Cantabria. And today, I wanted to talk about how to generate virtual analysis ready data for CMIP6 and ESGF. So I think we all know what ESGF is, but just to be sure, ESGF is the Earth System Grid Federation, which is a distributed infrastructure of research centers that collaborate to provide a unified access to climate data. And the climate data that you can find here is the one produced from initiatives like the Couple Model Intercomparison Project or Cortex. And yeah, this is very important data because it's used in the assessment reports of climate change from the IPCC. And the file format that is standard in this federation is netcdf, and the federation contains millions of files and several petabytes of data. Now, in the web portal, you will find something like this, in which you have two concepts here, the concept of a dataset and the files that made up the dataset. So dataset is a concept of a time series for a specific variable and a specific model, experiment, etc. But the actual data is stored in different files in small chunks, in small netcdf files, and this is done in this way because this is easier to manage in the federation, but this is an inconvenience for data analysis because let's say that you want to perform an average on this whole time series of a specific variable, then your program has to deal with all these small netcdf files rather than with this single logical unit. So one of the things that are most remarkable in the last few years in the community is the appearance of cloud repositories that have been set up by the Pangeo community. And the work here consists on an ETL workflow from ESGF to cloud providers. Now, cloud providers provide storage in the form of object store rather than parallel file systems found in HPC centers, which makes things a bit different. But the point here is that the curation of these repositories implies a duplication of the data. And for example, for CMIP6 in ESGF, there are 20 petabytes of data, including replicas, but 20 petabytes of data overall. And if you want to duplicate this data in the cloud, you have to assume the cost of duplicating this huge amount of data. Also, netcdf is no longer the format used because by default, netcdf does not work well in the cloud. So there is a conversion made to the THAR format, which is a very similar format. You represent your data using multidimensional arrays with attributes, but the management of the chunks is a bit different between the formats, and the THAR format is better suited for the cloud. Now, important thing here too is that the conversion from netcdf to THAR is not performed on a per file basis. Rather, each ESGF dataset is converted into a single THAR store, and this is very convenient for data analysis because this allows users to deal with the data in a unified manner rather than with small inconvenient netcdf files. So from my point of view, there are two key elements to success of these kinds of initiatives. The first one is the ability to access the data remotely using a URL rather than a local path to a local storage. And the second one is the capability of allowing users to analyze the data in an analysis-ready data manner. Now, I think that analysis-ready data is a new term for something that has existed for several years now, which is online analytical processing, or OLAP, which is the capability to analyze the data according to multiple dimensions. Now, you can see here how a system that meets these two criteria, for example, a Pangeo repository, how this looks like. Basically, you use your favorite client, in this case, XArray, to open a remote URL, and this provides you with access to a remote data cube, and you don't have to know how this is organized behind under the hood. And yeah, we have noticed here that this is the variable here is surface temperature, which if you look for this variable in ESGF or in a Pangeo repository, this is a 3-dimensional variable, but here this is a 4-dimensional variable because I have included here one additional dimension for the variant label, which in CMIP6 represents the different ensemble members of a particular model. Yeah, this leads me to the topic of today, which is this workflow, which I have called the ESGF Virtual Aggregation. And this is a workflow that tries to meet these last two criteria of remote data access and analysis-ready data. But this tries to accomplish these two things without the cost of duplicating data to another different infrastructure. So basically, the data it continues to be accessed using the data nodes of the ESGF Federation. And that's why I have called this virtual. And how I do this is implemented using a module from the NetCDF Java library, which is NCML. This stands for NetCDF Markup Language, which is very similar to Kerchunk, if you know it. This is a small XML files that allows users to aggregate different NetCDF files into a single logical unit. So you can map a ESGF dataset into a single NCML file, and the NCML file contains the locations of the NetCDF data, and it recovers the data from the NetCDF files on runtime. Also, the remote data analysis capabilities are offered in the ESGF through the deployment of a Thresh data server in all the ESGF data nodes, and the protocol used is opened up. And the way in which this workflow works is very simple. I just query all the ESGF index data or metadata, and I used this metadata to create all the NCMLs locally. And yeah, these are some numbers from this implementation. Here we have the ESGF repository, which holds 21 petabytes of data for CMIP6, and querying all the ESGF index, it takes me 24 hours, more or less, which is a large amount of time, in my opinion, but it is what it is. And with this metadata, I set up a local SQL database from which I generate all the NCMLs that I need to cover all the data from the Federation and CMIP6. And you can see that the NCMLs just take 67 gigabytes of size in disk. So this is a small amount of data of space required to store this. And there are also some inconsistencies in the number of files that are reported from the different index nodes in the Federation. But yeah, there are roughly 66 million files for CMIP6, and the last scan I did, it was on January 23rd, and I got data from almost 66 million files from CMIP6, and from these ESGF files, I generated more than 2 million NCML files. Now, not all of the files from the ESGF provide opened up endpoints, but most of them do. So there are 1 million files excluded because they do not provide opened up access, but most of the files provide opened up. And you can see here in this graphic how the NetCDF files are distributed in the NCMLs. This first column means that there are 26% of the NCMLs are made up of just one NetCDF file. And the second column means that 30% of the NCML files are made up of between 2 and 5 NetCDFs. So most of the files of the NCML files are made of a small amount of NetCDF files, but there are some NCMLs that contain hundreds or thousands of NetCDF files inside. So here there is an example from one large NCML. This particular dataset contains 2,494 NetCDF files inside. In this case, the data node where the data is accessed is this one here. And yeah, when we open this URL, the URL for this dataset with Xarray, again, we see that this is the surface temperature. There is also 4 dimensions now, 2. And in this case, there are 29 variant or ensemble members for this model. And if you try to open this NCML as it is generated by default from the ESGF Virtual Aggregation, you will see some errors because of some timeouts errors. And this is caused because when we open this URL, OpenDAP needs to know the size of the time dimension. And in order to guess the size of the time dimension, it needs to query all the NetCDF files in the server. So this involves making 2,400 HTTP requests to the server, which is a lot, and you will see that it timeouts in most of the cases. Now, there is a way to solve this because NCML allows to override the values of any variable. So we can hardcode the values of the time coordinate in the NCML. And this is what I have done here. I have read the values of line for the netcdf files for the time coordinate. I have written them in the NCML. And now there is no longer required to query the server to know the values and the size of the time coordinate. So once we do it, this works fine, and we can analyze our data. And this is a small test I have performed in which I load all the data from this array. So this loads 200 gigabytes of data, and it takes 2 hours and a half. So this gives us a throughput of 25 megabytes per second, which is not the highest in the world, but some workflows, this might be useful for some workflows. And also important to note here that there are two different sizes here. One is the size of the array in memory, which is the one reported here by xarray, which is the product of the sizes of the dimensions and the data type. And this size here is the size that these netcdf files occupy on disk. So this is the sum of all the sizes of these netcdf files. Now, because netcdf files are stored with compression, this is much less than the size compared to the in-memory version. And yeah, this leads me to this slide in which I compare the performance of OpenDAP with other methods for remote data access, mainly Thar and Kerchang. And when the point here is that when we access our data using OpenDAP, the data travels over the network in uncompressed form. So the chunks are uncompressed in the server, and then they are sent through the network. So for this specific example here, if we are reading the data through OpenDAP, we are transporting 20 gigabytes of data over the network, which is a lot. However, this is different in Thar and Kerchang because the chunks are read directly from the server and they are uncompressed only in the client. So this means that if we want to read this data using Kerchang or Thar, the amount of data that travels through the network is only 10 gigabytes of data. So this means that every time we use OpenDAP, and the ESGF Virtual Aggregation uses OpenDAP for this, we have a very big penalty here. And now this is a small experiment that I made to put some numbers on this. So you can see that when we try to read this data using Kerchang, you have the most efficiency because the data travels compressed over the network. And when you read through OpenDAP, now 20 gigabytes of data have to travel through the network, so it's much slower. It takes much more time. And also here in this case, what I have done is I have activated HTTP compression. And this means that when OpenDAP reads the chunk, it uncompress the chunk in the server. But before sending it through the network, the HTTP server again compresses the chunk and sends it through the network. So if you have a small number of workers here, you can see that this takes a huge amount of time because the time required by CPU to compress the data again is a lot. But if you have a huge number of workers, you get more or less the same amount of time. But the data in this case that travels through the network is much less because it's being compressed again. But still, Kerchang or Thar are the most efficient options here. Also, there are some issues with the data in ESGF. Mainly, most of the files in ESGF use a chunk size of 1 for the time coordinate, and this is very bad because this is the worst possible chunk size for a variable. This makes the V3 in the HDF5 file very large, and it takes a lot of time to read the values here. This is a small test that proves the previous. Basically, I have created two variables, one contiguous and one chunked with chunk size of 1. And for the contiguous variable, the data is read very fast, but when you use a chunk size of 1, the amount of time required to read the values increases very fast. Now, these are some of the applications for which the ESGF virtual aggregation could be useful. The first one is that it allows the creation in a cheap manner of a cloud native stores. Basically, what I'm doing here is I'm opening an OpenDAP endpoint from the ESGF virtual aggregation, which provides me with a dataset that is more or less analysis-ready data. And I only have to invoke this function in order to create a a third version of the dataset. Now, it's important to take into account that because OpenTab uncompresses the data before sending it through the network, the amount of data that is going to travel here can be very large. Also, I think this could be useful for as a kind of way for fixing metadata and data in the ESGF rather than overwriting the files. An NCML file can be created for the netcdf file which contains errors, and NCML allows to overwrite any of the dimensions and attributes and data values. So this could be useful for fixing some of the data in ESGF. And because the ESGF Virtual Aggregation offers analysis-ready data, I think this could be useful also for subsetting. Yeah, so just a few thoughts on this. On the good part of things, this is kind of a free lunch because it's very cheap to run and it provides remote access and analysis-ready data for all the data in the federation at a very small cost. However, we have the penalty that OpenTab is not very efficient because it uncompresses the data when sending it through the network, and this is much worse performance compared to other alternatives like Thar or Kerchunk. Also, ESGF data nodes do not operate on a commercial basis, so most of the time OpenTab endpoints do not work properly, and you have to contact the administrators, and it's not as operational as cloud storage services. Also, there are some ugly things. For example, for large NCMLs, we have this problem of the time coordinate, and I leave this question here. If ESGF index node could index information about the time coordinate, this would solve all the problems related to this particular problem of having knowledge of the size of the time coordinate. And also some more issues arise because some ESGF providers, data providers, split the time series of a variable in different versions of the dataset, because some part of the time series get uploaded one day, and the next day the rest of the time series is uploaded. So the data ends up separated in two different versions, and it's different to make the analysis-ready version of these datasets. And yeah, that's basically all from me. I just would like to show you that there is a Pangeo repository, a GitHub repository where all this work is published and you can reproduce it. It's very simple, as I have said. There is only two scripts, the one that queries the ESGF index that you can customize using very simple format files. And there is also a second script that generates the NCMS. And also it's a very simple script. And yeah, there is also a binder in case that you want to play with this. Well, this one has died. And yeah, I think that I'm done with this. We can open the discussion now if you want.
Okay. Thanks very much, Ezekiel. I'm going to stop the recording.